Okay. Okay. So we all now know kind of what machine learning is, right? Little bit about machine learning, right? We are here to predict, okay, what's going to happen based on the data. And we discussed about, or we know about two types of learning: supervised learning, unsupervised learning. So our focus is supervised learning, right? We'll focus on what is supervised learning. So before you perform any model, okay, before you perform any model, first thing that we need to perform is called uh, data cleaning. Okay, so let's say when you get the data, okay, and before you perform any model, before you perform any machine learning model, you need to analyze the data and make sure that data is in a usable format, is in a format which can be, okay, further used for prediction and things like that. Okay, so there are multiple steps that we're going to talk about. Okay, the very first step, or before that, okay, we will talk about step and also how to do it. Okay, um I'm going to share the GitHub link from where you can download the machine learning, okay, data. So let me take you to my GitHub quickly. You guys already know, okay, it's the same link, but instead of using data set, okay, for machine learning, I have another set of data set called this one. We'll be using this machine learning, okay, we'll be using this machine learning data set. And today we'll be using the first one, which is data pre-processing. So I'm going to save this link here in the code itself so that you have it. And today we will talk about this data set, pre-processing data set, okay? So you see this data, it has 4 columns here, okay? Now, by looking at this data set, what do you think? What is our intention? What can we do with this data set? What do you think? So, see, the way I read it as is
So
that,
based on
yeah, go
the
ahead, Sridevi.
so based on the region, we can group how many quotations we have given and which
Mm-hmm.
salesperson has performed well uh,
Mm-hmm.
by, I
So
mean,
how
how
do you
many
know?
quotations.
Yeah. So see, those are the quotation values, and each of these are each individual quotations. Okay.
Mm.
So now it could be the number of salespeople in the project or the age of the salesperson. That could also be the
Mm.
that number. Now what we see here is that when is what we want to know, right? So if
Yeah,
don't forget the fourth column, win. Okay.
when, yeah.
So so in a normal sense, okay, probably we want to predict whether can we win a sales deal or not based on these 3 values. So if the sales deal is happening in North region, and and if the salesperson's age or number of people involved is 44, okay, and the quotation that we have given is 72,000. Okay, so in
Mm.
this case, generally this particular case, we have lost the deal, right? The first
Yeah.
case, right? And second case, okay, you have south, 27, 48,000, and we have owned the sales cycle. So something in the south, okay, with lesser number of people and with lesser number of quotation, we have owned the deal. So point I'm trying to make here is that, this is the past data, okay? This is the
Mm.
data which has happened to your company before. You have kind of, the result, okay? This is from the past. Now, is it possible to use the past data to predict future? Let's say if I have a sales deal in South, okay, and if I have a sales people of 58, okay, and quotation of 65,000, will I win or lose? What does machine learning model say? Okay, what does it, helping me to predict whether, I will win or I will not win, right? So this is what we will be able to predict. Okay, now this is called as um, okay, here, this is called as supervised learning because you have the past data, you have the past result. You are using the past result to predict what will happen in the future. Okay. And the model that we're going to learn or model that we're going to use is called classification model, because the objective here that why, okay, win is categorical. Okay, so when your win is categorical, we use classification model. But again, I told you, model we'll discuss later. First, we'll make sure that do we have everything that is required to run the model, okay, or what we call as data cleaning part. Okay, and I'm going to take you through each of the steps. So first we will talk in terms of theory, okay, how it is done, and then we'll come back to this example and we will use that theory to do the programming. Okay, the now if I have to import this data, okay, if I have to import this data, so you see this data is missing here. For row number 6, the quotation is not there. Okay, row number 8, salesperson, the number of salesperson is not there, right? So what it means is we have to handle this missing value. The main, okay, one of the first or one of the important pre-processing that you will have to do is to handle the missing value. Okay, to handle the missing value. Let me take you to the code here and then talk about it, sir. Okay, handling missing values. Now, how do you handle missing values? What do you do with the missing values?
So we can replace it with a 0,
Okay,
or we draw, we
right. So see, you can drop it, right? Okay, we can drop it if, let's say, okay, now this one is similar to what we did in analytics. Okay, we can drop it if you think that most of the values in the rows, okay, are empty. So if you okay, if we have a row, okay, you have a row, okay, row is left to right, correct? Now in a row, let's say you have 13 columns, and out of 13, 10 are blank or 8 are blank, okay, then probably you have lost the important set of values. Okay, you may not have enough data to make any prediction. So what we do, we will drop those rows. We will drop those rows which have so many missing values. Okay, so one way is that if you think that lot of values, okay, lot of values in the rows and also in the columns also. Let's say, you have 10,000 values. Out of 10,000, okay, 9,000 are empty. So better you drop that column itself, right? So, if lot of values, okay, now there is no formula as such. See, when we talk about statistics, it is just about seeing and then making your decision based on that. Okay, so there's no rule that, okay, 70% you should keep it, 80% you should not keep it, or something like that. Okay, it is totally up to you, but preferably, like, when you have more than 50%, we tend to we will delete it. Okay, we will drop it, whether it's rows or column. Okay, okay. So so if as I said, if you have lot of values missing, better you drop it. Okay, so then how do you drop it? Okay, we'll see later. Okay, how to drop it. So I think we have already done dropping when we were doing the hotel example in analytics. Okay, so when you have a lot of values in the rows in the column missing, you drop them, you remove them, delete them, right? Okay, now if a lot of values are not missing, in the sense, let's say, okay, only 2%, 1%, 5% values are missing. Now if you drop them, okay, just because only 5% data is missing, okay, 5% data is missing, you're dropping 95% data. So dropping means you're losing the data, right? So that's not a good idea in that case. Okay, to handle 5% missing values, you are deleting. Okay, you're deleting 95% of data or 80% of data. Not a good idea. So in such case, what we do, we try to make it, because see, machine learning model that we're going to do, it's a mathematical model. Okay. If you give garbage, it will take garbage. Okay. It totally depends upon what you give, what what value you give. Okay. So if I okay, like it is different than your data visualization. Data visualization, you can give now 9 or 0 or whatever, and it will show up in the graph. So you can say that, see, this is missing value, and the readers and others people will not read it, will ignore it. But here it's not graph, it goes as a calculation, right? So you cannot give any number, because if you give -9, it will treat as -99, and it will perform the model, assuming that it is -99. So in such case, what we do is we replace with mean or median. Okay. So in this case, you replace, if lot of values are not missing, then you replace with median or mean in case of numbers. In case of categorical, you replace with mode. Okay. So we perform replacing of missing values with mean, median, or mode. Okay. Now, when you replace with mean, median, okay, the impact on the analysis is minimum. Impact on the analysis is minimum. Okay. So, you do not want to have that kind of impact on the numbers. Okay. So, so that's why, to have the minimum impact, we replace with mean, median. Okay. So, you can have there's a common question, right? How do you handle missing values? Okay. So, these are the two ways of handling missing values. The next can be, okay, handling, we call it as, label encoder, okay, or handling your categorical value itself. Okay. So what is categorical values? We know, right? Like, let's say in our example, it is north, south, east, west, correct?
Yeah.
Okay. Now you see this. Now, since it's a mathematical model, you cannot give text value as input, correct? You have to convert this into numerical values, 0.2, correct? So let me show you with an example here. Let me see if I have now. Okay, so you have region and we have other columns. Okay, let's say whatever. Now the problem with region is you have north. Let's say you have north, north, south, south, east, west, east, west. Let's say you have 8 rows, and these are the values in your region. Now, problem with this is, okay, when you are you cannot give input to the model in text. Model is mathematical model, okay, and it will accept only numbers. Okay, so you have to convert this text into numbers. So how can we convert this text into numbers? Okay,
we can assign a number to each division.
You can assign a number
region.
to each of this. Correct. Okay. So let's say, we'll go by nominal. In nominal, what happens? Okay. We'll assign them based on the alphabetical order. Okay. So instead of saying region as north, south, east, west, we'll say region underscore numeric region, let's say, and we'll say east is 0, let's say, right? And then after E comes N, So we'll say north is 1. And then comes south. We'll say south is 2. And then we say west as 3. Okay. Now, so yes, good. We have converted this region into numbers. But do you see any problem here?
When the repetition, right? We should
No, so it is
only put
repetition, north, north, right? So
repetition.
repeating is fine,
Yeah.
correct? Repetition means we are talking about north, right? So north is getting repeated twice, which is good, right?
Okay.
Okay. Now you see this, okay? When you perform, um, uh, this is called, label encoding, right? So we have encoded the label. We have encoded the categorical value into 0, 1, 2, 3. But see, for a minute, you forget that it's a categorical value. When you look at the number, what does it say? It says that, okay, west is 3 times more important than north. Now, we discussed that these are nominal categorical values, right? In nominal, all of them are equally important. You cannot say north is, more important than south, or south is more important than north. But when you enter these values in this format, it shows that east has no importance, right? It's east, its value is 0. That means it is absent. It's not at all important. Okay, and west is 3 times more important than north, right? Which is really not true. So we want the data to get into the model building in numbers, but this number should not give that feeling that one is more important than other, right? It's like, is it okay? I need to give you some numbers. So I give you number 3 to somebody number 0. Number 0 means that person is not at all important, right? That's what model will think. If you assign this to any mathematical analysis and any mathematical model, 3 will have more power than 1, isn't it? It will have more influence on the analysis than something which has 0. You agree? So, yeah, right? So this is not the right way to encode the model. Okay. So what we do generally is we break this categorical value into multiple columns. So, okay. So if you have a region with 4 values, this one column actually becomes 4 column. We call it as, so this is called label encoding. Okay. What we just did is called label encoding. But after doing label encoding, we have to do column transform. Okay. Column transform is to make sure that all of these values, categorical values, have equal importance. Okay. So you can say here region north, something like this. Region south, region east, and region west. So the data which has one column has got transformed into 4 columns. If you have 10 set of categorical values, you will convert into 10 different columns. If you have 2 columns, like, you have male, female, let's say 2 columns, you'll transform into, 2 values, then you'll transform it into 2 columns. Okay. So you have region, north, south, east, west. Now you mention. So region is 1, north is 1, right? So you make north as 1 and rest at 0. Okay. Now this gives a correct meaning. It means that north is present and all the other regions are absent, which is exactly what this means, isn't it? North is 1 means north is present and everything else is absent. This is again north, so you put 1 here. South, so south is present and everything else is absent. Okay, this is how the categorical values are converted into numbers. This gives the correct meaning. East is present, so we will put east as 1 and everything as 0. Understood? Any question here? Similarly, west is here, so we'll put west as 1 and everything else as 0. All right. So one column got transformed into number of unique values in that column. Did you understand? This is the second important a step that you'll have to perform in any model building. Second important step you'll have to perform in any model building is that you have to convert categorical value into numbers. And it's not straightforward convert numbers because you'll have to also make sure that the each of the columns retain their importance. Now, if I enter this as into the model, then you know that the north is present here, everything is absent here. North is present, everything is absent. South is present, rest of them are absent. Now they will not have different say, right? All of them have value 1. Now, after doing this, you can delete any one column. You can delete any one column and the impact does not change. Okay. If you have 100 unique values, you remove one, you'll end up with 99 unique columns only. Why? Because you see, if I delete any column, okay, not only west, you can delete east or north or south, any column you delete, okay, it still gives same meaning. Now, for example, here it means same, okay, here there's no question here. But when you come to this row, all of them have zeros. That means north, south, and east, all three are absent. Okay. Okay, which is also true. This does not change the meaning of the analysis. With me. This does not change the analysis meaning of the analysis. Okay. So to transform your numerical value or categorical value into numerical value, you have to follow 3 steps. What? First, encode it, then transform it, and then delete any one column. Any one column. Doesn't matter how many category values you have. You have 100, one is gone. You have 2, one is gone. Right? If you have male, female, one is gone. Okay, anyone. Did you understand, everyone? Okay, this is important aspect. Okay, this is what we need to, this is one important aspect of model building. Okay, converting this data into categorical data into numeric. Okay, and you have to perform little lengthier step. Okay, next is the third important step that you have to perform is called scaling. Okay, what is scaling? Now, in our example itself, you see that we have quotation and salesperson, right? Now, salesperson has values in double digit. Okay, but your quotation has values in 5 digits. 44,000, 73,000, right? 82,000, 54,000, right? 63,000 or 62,000, okay? 51,000, right? So you have values in 5 digits. Now see, within one column, it is understandable, right? When it is 24 versus, let's say we put 48, then we know that 48 is twice the age of 24, okay? Which is good, we don't have to worry about. But when you compare 2 different columns, you see the problem. Problem is that this column has 5 digits. Now, when we give this data for analysis, what happens, since quotation has a higher number of values or higher values, this is going to have impact on the analysis. So this is going to have a higher impact. It's like, it's like that, what you call, tug of war. And you have on one side, you have, one side you have Laurel, and other side you have Hardy. Right? This is like Hardy, isn't it? 45,000. And this is like Laurel, 2 digit. Now, when you have 2 digit and 5 digit, what happens? Quotation will always kind of, influence the result. Okay, age or salesperson in this case, okay, will not have that kind of say in the analysis. Yes. So your model is going to be a biased model. Model is going to be a biased model based on model is going to be a biased model. Okay. Biased towards whom? Biased towards quotation. You guys there? You guys can hear me now?
Yeah, I can hear you. Yeah.
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 Yes,
Okay,
sir.
yeah.
Yes, sir.
Totally silent. That's why I was wondering what happened. Okay. So yeah, tell me yes, no, so we'll understand. Yeah, you're able to understand. Okay. So your
Okay.
bias, your model is going to be biased towards quotation because quotation has a much higher values, right? Than salesperson. Again, you don't want to have a biased model. Okay. Now, within values, yes, 24, 48, there should be bias because you want, that value is higher. Numeric, that's what numeric value means. But in terms of column, all columns are equally important. Okay, you don't say that this column is more important than this column. Okay, so
Yeah.
what we do here, we do scaling. Okay, we do scaling, and in scaling, we try to bring them to a same level. Okay, we try to bring them to same level. Okay, and keeping the values in the column, so that it doesn't change the meaning. Okay, within column it should not change the meaning, but across the column, the the numbers should be in similar range. Okay, so what we do, as I said, we do scaling. And how do we perform scaling? There are two types of scaling. There are two types of scaling. One is called mean max scaling. Okay, one is called mean max scaling. Now, what is mean max scaling? Mean max scaling assumes that minimum value in any row is 0 and maximum value is 1. Okay,
Yeah.
so we will scale these values to zeros and one, to between 0 and 1. And again, we will scale this between 0 and 1. So your mean max scaling formula. Okay, so mean max scaling formula is, okay, x minus minimum value divided by max minus mean. Okay, x minus mean divided by max minus mean. We are dividing, okay, the values this way. This is called mean max scaling. Okay, so if we have to use mean max scaling, okay, what is the minimum value here? 24, right?
24,
24, yes. And what is the maximum value here?
56,
78, correct?
78.
78, right? Okay. So what we'll do is, okay, so salesperson after scaling, okay, scaled value. So after scaling, it's going to be, okay, x, which is 24, minus minimum divided by max minus mean. Okay. Now K2, let's fix it. Okay. So we'll put $sign. That means this value will not change. Max also is fixed. So we'll put $sign. Okay. Here also we'll put $sign. Okay. So max, x minus mean divided by max minus mean. So this is minimum, so it will be 0. Okay. And now you drag it till the end. So you see, minimum value became 0 and maximum value became 1. And everything else, okay, has been scaled to the same scale, to the same level. Okay. So highest, second highest is what? 56. So here you see, it is 0.55, 0.59, right? 0.49. So 56 is closer to 78, right? So that's why it's more than 0.5. Okay. So we have scaled it between 0 and 1. Same thing you do here. Here, minimum is 44, right? So we'll mark it at 44. And maximum is 82. Correct. Maximum is 82. So same thing we'll do here now. X minus mean divided by max minus mean. Okay, and again we will fix all these values. So we'll fix mean, we'll fix max, we'll fix mean, and hit enter. Okay, now you see maximum value became 1, minimum value became 0, and everything is scaled between 0 and 1, right? So this is your mean max scaling, and you see data has been scaled. So what happened? The relationship between data within that column, okay, column is same, but across the rows, okay, they are in same range now. Okay, values we have zeros between zeros and 1. So this is not going to have any biasness based on the value itself. Yes, because they look as same. So what happens is in the analysis, we don't send this. Instead, we send this. We will use this in the analysis. Okay, still our model will perform very well. See, model doesn't need to know exact value. Model what needs to know is how much is what impacting and things like that. So this is good enough for us to know what is happening. With me? So this is called scaling, and this particular step is called mean max scaling. But we generally don't use min max scaling technique. Okay, we use what is called as z-score normalization. Okay, so we don't use mean max scaling. We use z-score. Okay, so z-score normalization. Okay, so z-score normalization is based, as the name suggests, z-score is based on your standard deviation. Okay, let me bring it down here. Okay, it is based on standard deviation. So instead of between zeros and 1, we we convert it into your like based on the standard deviation. Okay, so based on standard deviation, 99.9%, right? What is this 3 sigma? 68, 92, 99, right? 99.7. So 99.7% of data points will be between -3 and +3. -3 is standard deviation on the left side, and +3 is standard deviation on the right side. Okay, so z-score normalization will be done based on standard deviation, and the formula is, okay, the formula is your x minus, okay, a mean of x and divided by mean of x, bracket close, divided by standard deviation is standard deviation. This is the formula. So what is the mean of x and standard deviation? Okay, so mean and standard deviation. How do you calculate mean and standard deviation? Mean is average, isn't it?
Average.
So simply you say average of salesperson, right? So let's say this is your salesperson scaling, SP scaled, and this is your quotation scaled. So this is your mean, and the mean of, okay,
scaled values.
Yeah, quotation scaled is this one, and standard deviation. So we say STD right? STD standard deviation here P, Pearson standard deviation. Okay, so STDEV dot P, and this of salesperson is 17.4. Is it correct? Okay, if it says it's correct, so we'll assume it's correct. And this is your standard deviation. Okay, now this scaling value is going to be, we said x minus mean divided by standard deviation, right?
So
So,
the
yeah.
second column in the z-score normalization, it's
Uh-huh.
mean and standard deviation of quotation.
Yes.
Okay.
Okay. If you click on this cursor here, you see it says average of L2 to L7. L2 to
Yeah.
L7.
Okay. Okay.
Okay. So now we will fix this R. Okay. So F4 and R11, and we will drag it down. Drag it down to the last value here. Same way, we will fix the mean and standard deviation value. Oops, did I make any? No. F4 and F4. And you bring it down. Uh-oh. Okay, so, using Z scale, this is what you have. See, most of the values are between -3 and +3 only. Okay, this talks about the
Oh.
spread. So this is what we generally use for our analysis. Okay, so we have seen three, three steps of data cleaning. One is to handle the missing values, other to do the label encoding of the categorical values, and third, scale the value. Now see, yeah, scaling. Now see, if we had these values in same form, let's say if this was also 5-digit, okay, and this was also 5-digit, then there was no need to do this scaling. See, if there is both the side Laurel or both the side Hardy, then we don't have to worry about. Correct?
Yeah. Okay.
Right? But problem is one is too big and one is too small. That's when you have to do scaling. Okay, you can do scaling
these
as
are, but these are different. They're communicating different meaning, right?
they're
Like,
communicating different meaning. Okay,
but still,
but
we need to make them look the same for
see,
the model.
yes, because the sales. But forget about this data for a minute. Okay, salesperson and quotation. Do you want salesperson to have more influence about on the analysis than quotation? No, right? In that case, you don't add salesperson. You use quotation only. The answer, the model, if you give only one value as input, answer will be almost same whether you give one or both, because this is
But
anyway going to have more influence on the analysis.
so if we want to know, like, how many salesperson should I recruit for next year in this region?
No. So answer you will get in terms of Z score only, right? Now you can convert it back into the actual number.
So we can convert back.
You can convert it back. Okay. Now, the point here is, again, your question is wrong in this context because these are the input values, right? We are doing on the input. We are not doing the output value. Your win is the output value. Win is what we want to predict, isn't it? So it's not about how many salesperson. The question should be, salesperson is given, salesperson is input. If this is the salesperson, then how much should be my, okay, what is my win chance, whether I'm going to win or lose? So you are not predicting these values. These values are not predicted. Okay.
We
These
are
values
predicting
are
whether we'll be winning in that region.
Exactly. Now, because see, if you're talking about your Y will be only one column. I told you, right? The analysis that we're going to do, we have only one value of Y. We can't have more than one value. So if the Y value is only one, then no need of doing scaling anyway, right? It's when you have two columns and they have different ranges, that's when we do scaling.
Okay.
Okay. So all these steps are done on the input data, the data that is going to influence the output. All this analysis is done on the data which is going to influence the outcome. Okay. So we are performing, whether it is missing value, whether it is scaling, or whether it is encoding, is all done on the input data. Okay.
So in case of numbers, then it's the digit value only. Like if we see like 5 numbers, the other one is not 5 digits, sorry. Then we need to, is that the only criteria, or there are different ways of looking at it?
That's the only criteria.
Okay.
Okay. So I said, right, if you see that both the side, and see here we have 2 columns. You can have 5 columns or 10 columns, right?
Yeah, we
You
can
have to
have.
look across 10 columns.
Oh,
Okay.
okay, okay.
So compare all the 10. If all the 10 columns are in same range, then you say, okay, let's go ahead and do it. No, if
Okay.
even one is out of range, kind of, okay, then it's better you perform scaling on all.
So, like, if there is like one column, say there are everything is in thousands value, the other column is in like everything is like 6,000s or 7,000s, but the number of digits are the same, but the
Right. Okay.
one, what do we
Correct. So I
do?
got it. So it is, let's say it's 1,000, 1,005, 1,010, and here is 5,000, 6,000, 7,000. Okay.
Yeah,
Now,
yeah.
again, now, okay. Now, if you think there that it's not going to have much impact, then let it be. Okay. You don't have to do scaling.
Okay.
But if you think that no, it's better, let me do scaling. Doing
Mm.
scaling is not going to harm.
Oh, it's
Okay.
not going to happen.
Okay.
Okay.
Yeah. Scaling is not going to harm. Why we don't want to do is, it's going to take extra effort, extra time, right?
Oh, okay.
Right? That's the only purpose why you may not want to do scaling. Okay.
Okay.
But otherwise, scaling is recommended. Okay. So if you do scaling right, you don't have to use your logic. Should I, see, should I do it or not? Should I do it or not? Let's do it. Okay. That's what
Okay.
the answer should be. Okay. If you are in a confusion, should I do it or not? Do it. Doing it will not harm you, but not doing it can harm you.
Okay.
Okay. So when in doubt, do it. That's what?
Do it. Okay.
Yeah.
So one more thing, like that label
Yes.
encoding to column transform.
Mm-hmm.
But what do we call that? Like, is there a
Yeah.
term
Level
like?
encoding column transform only we call it.
Oh, we call it. Okay.
Yeah. 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 We'll see,
Okay.
and I will, I'll do it now, and you will see. All right. One thing which I'm not going to do here, but you have to keep in mind is the outliers. Okay. Are there any outliers in the data set? And what do you want to do with outliers? You might want to remove those outliers. Let's say, so here you have everything like salesperson, everything is double digit, and there's one row with, 2, 3, 4, 5, 2003. Okay.
Oh,
Okay. So
that's an
maybe,
outlier.
maybe you just remove it. Okay. Now again, see, removal decisions that you take should be in such a way that removing data should not influence. Let's say if you have 10,000 rows, and if you remove 2 or 3 rows, it's not going to have any impact. But if you have 10 rows and you remove 2, it's going to have impact.
Yeah.
Right. So that's what, outliers always means that it will be 1 or 2 out of 10,000. That's when we call outliers. And see, here for our purpose, I'm doing 5 or 6. Okay. But when you do actual project towards the end, okay, when we do actual project, you will see, okay, the rows will be in thousands at least. Minimum will be 10,000, right? It will be more than that only. So out of that, if 4 or 5 if you remove, doesn't matter. But out of 10,000, if you remove 5,000, then you're left with nothing. I mean, so that should not be the case. So always try to correct the data. Okay. And if you can correct the data, great. If you can't correct the data, okay, then better, okay, remove it. Try to correct. Your option should be as much as to correct the data. If you can't correct the data, that's when you remove it.
Okay.
That's when you remove it. Okay. So these are the steps in data cleaning. What do you do with data cleaning? The last step that we do is called converting into training set and test set. Okay. Let me take you back to the code that we are writing. We have not started writing the code. So second one is categorical data, right? What is the third one? Scaling.
Scaling, yeah.
Okay. Now, when you are done with your data cleaning, then we perform what is called as converting training set to, sorry, not converting, okay, creating, okay, creating training set and test set. What are these? Okay. Training in supervised learning, training is an important aspect. Okay, you are training the model. Now, if I ask you to do a job without giving you training, can you do the job? You can't do the job, whatever job it is. You need to
Mm.
train the person who is doing the job. Same thing when you are saying the model, I want to use the model. First, you need to train the model sufficiently. You have to tell the model that train, learn it, learn it, learn it. Why are we doing
Mm.
this? Why are we doing this course? We are doing this course because one fine day you will be doing this in your office work in a real-time situation. So you have some idea, okay, beforehand, before you actually do that in real time, right? So this is called training, right? As a human being,
Mhm.
we go through training. Similarly, we have to train the model. In the training, model understand the relationship. In the training, model understands the relationship between the data. Model understands the relationship between the data. And with that training, they are able to perform, okay, in the main situation, in the main prediction. But you also have something in between called as test phase. To test how well the model has learned, right? So example is, we have this course where you're learning. After learning, before you get into job, you'll have interview phase, isn't it? What is interview phase? Interview phase is testing you. How well have you learned? If you have learned very well, that's when you will be allowed to work on the main project. You will be hired and allowed to work on the main project. Okay. Otherwise, you will not be allowed. For what are every company, they do the interview, right? They evaluate how well the person knows, your team knows, right? Before they put you in the project. Yes or no?
Yeah.
Okay. Because if they don't test you, and if you go and you know uh then you make some mistake there, okay, that's not going to be helpful for the business, right? So similarly, we have to train it, okay, and then we have to test. Let's say if I am the teacher and I train you, okay, after training, how will I test you? I will test
Yeah,
you, see,
with the project or something.
with project something. So I can only test you with the things for which I have the answer, I know the answer, correct? If
Mm-hmm.
I can't test you by giving you a project which I myself have not done it or I myself don't know, correct?
Yeah,
That
yeah.
if I don't
Mm-hmm.
know, then how will I know whether you have done correctly or not? So what happens? Every teacher, what they do is, if they know 10 things, they'll teach you only 8 things, right?
Mm-hmm.
Why?
Mm-hmm.
Those 2 things they keep it for testing. If same thing, if I teach you, and same thing if I take a test, that's not a good way of judging your capabilities. Okay, if I give you a problem in the class and same problem I
Mm-hmm.
give you as assignment, is there point of doing
Mm-hmm.
the same thing as assignment? No, right? Because we have already done the class, then doing assignment does not make any sense. So how will I know whether you have copied from the class or you have done it on your own? Right? See, if I have to
Mm-hmm.
judge, see, um, I'm assuming that you are doing practicing. Okay, but if I really have to test you, I have to ask you a problem which is not done in the class. Otherwise, let's say you come to me with solution. You said that yes, I have solved this problem, and you have come to me, so I have solved this problem. But I will have doubt whether you have done on your own or you have gone through the recording and you have done the problem again, right? So same thing with the data here. If I test you, if I train you on X data, and again if I test you on the same X data, I will not be able to know whether the model has learned it or model has by-hearted it.
Okay.
Okay. What is test? What is training? Training is you give the X value. X values your input values. And input values will be multiple columns. In this data set, region, quotation, and salesperson. These are the input data, X data. We call them
Mm-hmm.
as input. We call them as independent variables, input variables. Okay. Okay, or X. X can be multiple. Here we have 3, or in fact, if you see, the 3 became 5. Region became 3 columns, and then you have 2 columns here. So 5 columns is the input, right? And output is 1 column, Y. Y is your win. Win is your Y, predictor, also called as predictor, or dependent variable. Dependent.
Mm.
Why is dependent? Because the answer of Y is dependent on X. So X is
X. Yeah.
called independent variable. X is called independent variable. Okay. Y is called dependent variable. Okay. Y is also called your predictor variable. Or Y, we represent it as Y. X's are your input values. So when you divide the data set into X and Y, first you have to break it. The whole data set has to be broken into X and Y. Okay, so you break into X and Y. Then what we say is, okay, if there are 10 rows, let me put 2 of them, we will hide it, okay, which we will use to test the model later. Okay, so if you have 10 rows with Y, okay, okay, for training you give both question and answer, right? While training, okay, I'm also asking you the question, I'm also giving you the answer, isn't it? That's how you're
Mm-hmm.
learning. But when I test you, I will only give you the questions, not the answer. Correct? And what the answer that you give me, I will compare with the answers which I have to see how well you have done. That's why I'll be able to judge your answers or test you. So if I have 10 set of values, generally 20 to 30% is kept aside for testing. So if I have 10, what I'll do, I will hide 2 rows and I will give you 8x and 8y. I'll tell you, these are the 8 questions, these are the 8 answers. I'm training you based on these 8 values.
Mm-hmm.
Then when you say, oh, I have got trained, I know now everything. That's okay,
Mm-hmm.
now let me test you. And I will test you on these 2 rows only, because see, I need to have the answer to test you. So I will
Yeah.
give you this time only x to test. To test, I will give you only x. I'll say, okay, you have learned it. Now give me the prediction for this x. And whatever prediction you give me, that prediction I'm going to compare with the y which I have not shown you, but I have it with me. The 2y which I have not given you. That is like
Mm-hmm.
answer key for me. The answer that you give, the answer the model gives, okay, that answer, that is called as prediction, and actual is what I have. So I'm going to compare actual and prediction and see how well you have predicted the y value. That part comes in model evaluation, we will see later. But here in pre-processing, okay, step, this is what we are talking about today. Pre-processing, you break the data into X and Y, and training set and test set. You give the training, you show that these are the training set, these are the test set. Okay, training and model validation is done after the model is run. Models, okay. So in pre-processing, the last step is keep your training set and test set separate. In fact, let me put here. Okay, third is like handling outliers. Okay, and we'll make this as 4 and we'll make this as 5. These are the important 5 steps that we do as part of pre-processing, data pre-processing, before you get down to model, okay, algorithm and things like that. Okay, replace the missing values, or not replace, handle the missing values. That's the right word. Handling the missing values, it could lead to replacing or deleting. Second is handle the categorical values. Third is handle the outliers. Fourth is scaling. And fifth is training set and test set. Okay. Do we have time? Do we have another 15-20 minutes?
Uh-huh. Yeah. No, I'm good.
Jamit and uh, Mona Lisa, we have 15 minutes?
Yeah, we can.
Okay.
We
So
can.
yes. So I'm going to do all these and then I'll tell you why scaling is done after training set and test set. Okay. So though I'm talking about scaling before training and test set, once we are done, I'll tell you we need to do the scaling after creating test set and train set. Okay. Why? Now,
Mhm.
let's say let me go back to Excel. Okay, once again. Okay, now let's say I have X, okay, as 2, 4, 6, 8, 10. Let's say I've got X as 2, 4, 6, 8, 10. Okay, this is after step number 3. Okay, removing outlier, missing values, okay, and category value. Okay, after doing all this is what I have. Now I need to do scaling and I need to do training set and test set, breaking into training set and test set. Correct? Okay. Now let's say I do scaling. Okay, I have done scaling, and after this, the result is, okay, after scaling, result is 2, 4, 6, 8, let's say. And now let me remove these two values from here. These are two values I'm keeping aside for testing. And you give 2, 8, 10 for training. Okay. So what I did scaling, I got the answer, I removed it, and now I've given this for training. So this is situation where you are doing scaling first and breaking into train set and test set later. Are you with me till this point? So I did scaling first, and now I'm giving this 2, 8, 10 for model to learn, for test, training. I mean, training is to learning, right? And then we'll perform test. Now what happens if I give you a value like 2, 8, 10, let's say you have more values yet, 14, 16. Now, when you get this data, you will be able to guess, oh, see here, 2, 8, and 10 is there, 12, 14, everything is there, like multiples of 2, 2, 2, right? 4 and 6 is
Yeah.
not there. So it'll say
Yes.
very likely question number 4 and 6 will come in the test. Our mind will go like that, isn't it? Similarly, model also will be able to relate, oh, 2 and 6, 4 and 6 are missing. Most probably 4 and 6 are the questions that are going to come in the exam. Right?
Okay.
See, when, just like when the teacher gives you important questions for exam, we start trying to do the correlation. Okay. Similarly, when you do scaling and then you do the training, breaking into training set and test set, then you will always end up, getting that doubt. Oh, there could be data with missing data, which could be the question. Okay. So you do not want to keep that correlation between scaling and the test set kind of correlation. So what we do, we first break it into train set and test set, then we perform scaling. Now, when you perform scaling of this, okay, now see, if I had performed scale, let's say we have 2, 4, 6, 8, right? Mean max is easy to guess, so easy to use. So let me use mean max. Let's say you have 2, 4, 6, 8. Okay. Now, when you do 2, 4, 6, 8, okay, and you do mean max scaling. Okay, so I'm doing scaling first and then training. Okay.
Okay.
And in this case, second case, we will do
Training first.
Training first and then scaling.
Scaling.
So we'll do training first and then scaling. So here, if I do training first, so I'm putting 2, 6 aside and I will do scaling now. Okay. And here, if I do scaling and then training. Now, if I do scaling here, then 4 and 6 will also be part of the main scaling. So if you assume that this is 0 and this is 1, okay, these values will be with respect to 2 and 16 only. So now when you take these two out for training, okay, there will be some gap here which you'll be able to guess. But if I do divide here and do scaling here, this will be 0 and 1 kind of. Okay. And this is going to be your 0 and 1 here. So there is no connection between 2, 4 and 2, 6 and this one. Okay. But here when I do scaling, there will be some connection between 4 and 6 with respect to 2 and 16. So it is easy to predict the question paper, right? And here it is totally not possible to predict because you have already removed the question and now you're doing the scaling. You're doing scaling as if 4 and 6 is not in the data set. So this is what I'm saying, that, as a student, you'll be able to guess this. Okay, so machine can guess what is missing, and 4 and 6 is missing. So 4 and 6 is what they want me to predict later. But here it is totally new values. There's no way you can actually think that 4 and 6 will come in the exam or in the test. Exam in the sense test for the model. So that's why, okay, it's not a big deal, but we prefer to do training test before scaling. This is another important interview question that they can ask you. Okay, and not an interview, practical also, this is what we do. Scaling is done after you break into train and test set. Because you do not want to have any kind of correlation between training data and test data, which model can predict.
Okay.
Okay, so that's
So
why.
then before scaling, one more step is then dividing into training and test
So
data
let me go
sets.
back here. So you take this step number 5 here and step number 4 here. So this becomes 5 and this becomes 4. So there's no new step, just that steps are reversed. This is what you do. After, yeah, go ahead.
And we only do scaling on the training set first, and
no, you have to do a test set also, right?
So yeah, but first training and then
correct. Because whatever you do on training data, same thing you have to do on test data also.
Test data also.
Okay. If you're not doing on training, don't do it on test. If you're doing on training, do on test. So you have to do 2 steps, okay, together. Okay, we have to do 2 steps together. And then we do the model building and evaluation and things like that. So we will finish off these 5 steps today. And then tomorrow when we meet, we'll talk about model building. Okay. So Jamit, we are targeting to meet every day. Okay. And hopefully in 1 week or 10 days, we should be able to wrap up. Okay, Jamit?
Okay, sir. Okay, sir.
Okay. Okay. So sure. So let's get started. So before we handle this, we have to read the data. So let me go back and get the link of the data. Let me see if that link is working now. I'm going to hit on raw. And luckily, this link is working now. So I'm going to take this and say here, link equal to, okay, you all know, right? You have to hit on the raw version, raw file. Okay, click on the raw button. You will get that link. Okay. Now I'm going to say import numpy as np pandas. Okay. As pd. Okay. Now how do you read the data? You say data frame equal to pd dot read csv, correct? Read csv and you give the link here. So now data is available. If you want to print and see, say print df. Okay, so this is the data. Region, salesperson, quotation, and win. Now let's divide this into X and Y. Because we don't have to touch Y, right? We only have to perform all this analysis for X and Y. So let me divide this into X and Y. So your X is going to, generally we write capital X because X will have more than one column, right? So, okay, it's up to you what variable you use. Generally, I prefer capital X to indicate that, X will have more than one column here. So X equal to, okay, data set, okay, or not data set, data frame, right? We have data frame dot ilog. Ilog means I want to refer them by numbers, integer, right? I for integer. I want X to have all rows and all the columns except -1 column. So starting from 0 up to -1.
-1.
Right? So -1 indicate up to the last
Dot.
column, dot values.
Yes.
And now for y, it's going to be, okay,
Same.
not same. Here we don't want all the columns, right? We just want last one. So remove the column.
Yeah.
Okay. And if you want to see the result, you simply say print
X.
x
X.
and print y. See, x will have multiple columns and y will have only one column. So
One
when you run
column.
it, yeah. Oops, y is not defined. Did I say
Y,
capital Y?
uppercase.
Yeah. Okay. So this is your x north 4472,000. You have nan here. We'll see next step. And these are your y value. Okay.
Yeah.
Now comes this important matrix, sklearn or scikit-learn. Scikit-learn is a package which will do all the work. Scikit-learn, okay, package. This package does everything, okay, for machine learning. For deep learning, we're going to use different packages. We'll use TensorFlow and Keras. But for machine learning, scikit-learn is going to do everything. Scikit-learn gives capability to handle missing values, column transform, you're breaking into training set, test set, doing the scaling, running regression model, classification model, clustering model. Okay, everything scikit-learn has. So you need to install scikit-learn. If you do not have, you need to say, okay, sklearn or scikit-learn or sklearn. You need to install this package. We call it as scikit-learn, okay? And generally we write it as sklearn. Okay, what happened? 1 second. One second. Got this. I'll just disconnect it. Okay, yes, I'm back now. So you need to pip install, okay, pip install scikit-learn, scikit-learn, okay, scikit-learn, okay. So it's scikit-learn, okay. This you have to do it to install the package, okay. So once you install the package, you can start using it. So first step is we have to handle the missing values, right? So the module that we use is called simple imputer, or class rather. The class that we're going to use, class simple imputer. We will use class simple imputer belonging to sklearn, okay, which is your scikit-learn. Okay, so class simply belong to sklearn. We will use to do the missing value. Okay, so I'm going to say from sklearn dot impute, okay, import simple imputer. Now we'll create an object of this imputer. So I'm going to say imputer equal to, so this is the object, imputer is the object, and I'm going to say simple imputer. I'm calling the init function. I'm calling the init function of simple imputer. That's why we learned Python, for understanding all these things. Otherwise, we didn't have to spend, a month on learning Python. Okay, so this is how we are using it. So simple imputer. Now here it has a value called as missing values. This indicates which values are missing. So have to indicate, okay, which value should I remove? You say np.nan. You see here, these are your missing values, right? So these are your numpy nan, not a number, and nan stands for not a number. So I'm going to say that missing values are indicated by np.nan. I said, okay, great. What strategy you want to use to replace? So strategy that I want to use is mean. So you say mean or median, whatever. So if I say mean, it's going to replace those missing values with the mean of that complete column. Okay.
Oh,
So object is ready. Now we have to call the object. Call the object on what? Okay. So I'm again going to say imputer equal to imputer dot fit and transform. Okay. We are going to use, see, whenever we are creating object, now this is with respect to the machine learning work that we're going to do. Every time, okay, so I mean, not every time, there are 3 steps that we need to perform. First step is create the object for the class. Okay, so we have created the object. Next is fit, tell what to do, and transform will get the result done for you. So we need to perform fit and transform. Some objects will have fit and transform together. They will do fit and transform at the same time. Some will need to call it separate fit and transform. But this is the step for every class. Call the object, perform fit, perform transform. After transform, you have the final expected result. So I'm going to call fit here. So fit is to tell what you want to do here. So I'm saying in the fit, you take x, okay? Now, x, should we pass complete x? Should we pass, this is complete x. Should we pass complete x?
we want to clean
You
only the
can,
third.
you can give complete x, but problem is, this is still text, right?
Yeah.
Okay. So in this case, this mean is not going to work. This is going to
Yeah.
give us error. This mean is not going to work. This is going to give us error. That's why we will not use complete x. If we had numbers here, we could have used complete x because it will calculate mean. See, we are not replacing this. This column has all the values. We are not replacing, but we won't be able to calculate mean here. So let's try to give this and see what happens. Okay, when I do this, okay, still running, right? Okay, it's performing. Impute, let's see. See, could not convert string to float north because mean works only on float or integer number value. It is trying to convert north into mean, right? It's not going to work. That's why we have to hide column 1 from here. So all rows, okay, and give all the values from 1. So this is how we give the column. So except 0, right? We are saying we are not giving 0. So from 1, go up to the end of x. Take all the columns for x. Don't take column 0. Right? Now you perform transform. Transform, if I say x equal to transform, I will lose the old values of x. Okay, so what happens here? So I'm going to say imputer dot transform. Imputer dot transform is not coming. Imputer, yeah, it should come. Okay, transform what? Transform same value. So this is what you need to understand and do it. Now if I, okay, let me hide x and y from here and we will print the x after this step. Okay, so we are replacing x with this new value. Okay, you see this? 4.4 power 1, that means 44, right? 44, 27, etc. But see here, 3.75,
Correct.
that means 37.538. This has replaced with the missing value here, and this missing value is replaced. Right? So it has replaced the missing values, but we have lost the column here. So that's why what I'm going to say, I'm going to say x of 1, 2, 3, right, equals this. Okay, that way we are saying 0 will remain. So x is column 0 will remain. Now you will run. See, same thing, but the column 0 is also remained. So we successfully have done missing value, replacing the missing value. We have successfully replaced the missing value. Correct? Next step is encoding. So what I'll do, I'll stop here for today, okay? Because encoding has few steps. Okay. What I'll do is I'm going to move this to step 1. Because these are small part of step 1, right? I'll put it here. We'll meet tomorrow and we'll do categorical value. Okay. This will take some, 3-4 steps, right? We have to first encode, then we have to transform, then delete. 3 steps in it. Yeah. So we will do this tomorrow, okay? And tomorrow, hopefully, we
Yeah.
will wrap up this and we'll start talking about what regression is. Any question
So
before?
this,
Yeah.
so
go
all
ahead.
this comes under classification.
No. These are your data cleaning process,
Oh,
which is
data
common
cleaning, yeah.
for any model.
All,
Okay,
Okay.
all the
pre-processing.
models.
We call that pre-processing. Because once you have data
Pre-process.
only, you can run any model, right? So
Mhm.
any machine learning algorithm you touch, irrespective of what it is, you have to perform all these. Once
So
we
then
have the
you
training
said,
set and test set, then we get into each of the model building.
okay.
Yes. You were saying something?
No, like